Okay, friends, let's take a look at these next few here. I definitely think it's a little bit simplistic to think that you're only paying for gas and you're buying the car. So I threw some other things in. We're still going to pay $250 a month for gas, so that's $3,000 a year. But let's go $800 a year for insurance and $50 a year for an oil change. I better write this down because I forgot it already. So we got to do $3,000 for gas plus $800 a year. That's $3,800 plus $50 a year. So that's $3,850 a year per year. Total cost is equal to $5,000 plus Y, which is the number of years, times $3,850. $3,850. Yeah, that's a good model. Make it a little bit bigger so we can see it better. There we go. Center it there. That's a good model. That's how much the whole thing's going to cost you after a certain number of years. Okay, let's once again use sheets to look at the total cost of the car using our new formula from 16. Yep, for sure. I think I'm going to go back and edit the old sheet. So here's the old sheet. I'm going to delete the spreadsheet, change this to number of years, and I think I said to go down to 10, so I'll just delete everything past that. I don't know how long do people hang on to cars these days. I'm not sure. Maybe 10 years. My family holds on to them to a lot longer, but we're old people. All right, so we come over here. We're going to edit the formula, so it's still $5,000. We're going to take the number of years, but we're going to multiply it by $3,850. And that's going to give us the new model. We have to pull that down to autofill. And there we go. That's how much the car is going to cost us if we work in insurance and an oil change every year. Now, of course, this also assumes, number one, that gas costs stay the same, number two, that insurance costs stay the same, and number three, that oil change costs stay the same. And we know those three things are not true. That's why it's important to make sure that those numbers are good averages. We spoke about this on your exam, about scaling up with dimensional analysis. And you got to make sure that when you make assumptions like this, you're making good assumptions based on good estimates of the data. All right, I think I asked about, what's the total cost after 5, after 10? So we go back to here. There's the total cost after 5. There's the total cost after 10. So $24,250 after 5 years and $43,500 after 10. How's this cost changing from year to year? And then how is this related to number 13? Number 13, if you recall, was asking the same question when it was month to month. And I think you'll see, it's pretty clear, I think, how it's changing. You're adding $3,850 every year. And again, that is the slope of the model, the average rate of change of the model. And I asked you to make a scatter plot for practice. We will do that again. Chart, scatter. There we go. And there she is right there. And, we can add the line again if you want to, but you can see the slope, the $3,850, because every year you go over, you're popping up 3,850. Over 1, up 3,850. Over 1, 3,850. I know we're not to scale. Can't really equate a number of years with a dollar. In this case, the number of years is 3,850, and this looks like a pretty shallow slope, but you got to remember each of these jumps right here is $10,000. So what appears to be a small jump is actually close to $4,000. You can make it look a little bit more extreme or a little bit more realistic, I guess, if you pull the graph down and make it taller. That does steepen the line. You can also push the graph like that. All right, let's do some more.